all the recent severe weather we've been experienced here in the Midwest these past couple weeks, I have chosen to inform you about how to categorize tornadoes. Living in the Midwest favors the development of the largest and the most dangerous tornadoes. According to AccuWeather, there's been over 1,000 tornadoes that hit the U.S. each year. An average about 60 people are killed per year from falling debris from the tornadoes. I am credible to give you this information because I have taken classes in weather and climate, and it's been a great interest of mine. Since it is impossible to measure the active wind speed inside the tornado while it's taking place, scientists had to come up with a way to measure the wind speed after the storm has passed. A severe storm research scientist from the University of Chicago, Theodore Fujita, came up with a scale in 1971. He had two goals for the scale. And the first one was to categorize the tornado by the intensity and area, and the second was to estimate the wind speed associated with the damage. This scale was put into use in 1973, and he categorized the tornadoes from F0 to F5. F0 was the weakest, and F5 was the strongest. F0 had wind speeds of less than 73 miles an hour, and F5 had the wind speeds of 261 to 318 miles an hour. However, there has been weaknesses associated with this original scale, and they needed to be updated to fit today's standards. An example of a weakness was that it did not differentiate between different constructions. An example of that is they would rate the tornado the same if it blew down a trailer home versus a hospital or school. So it needed to differentiate between the structures of the buildings. And another example why it needed to be fixed was because it was difficult to apply with no damage indicators. And an example would be if a tornado passed through an open field versus an area with more population and more buildings to destroy, they would be ranked differently because the open field tornado wouldn't damage anything. And another reason was that it overestimated the wind speeds greater than an F3, and an F3 wind speed was between 158 to 206 miles an hour, and they felt that that was too high, so they needed to adjust the wind speeds of the ranks. So in 2007, the scale was revised, and now it's called the Enhanced Fujita scale, also known as the EF scale. And the differences between the two scales was the wind speeds. Here are the wind speeds of the EF scale. Now the EF5 is categorized above 200 miles an hour for the wind speeds, and before it was above 300. And it also uses different charts to categorize the wind speeds. It uses a 3-second estimated wind gust at the point of damage, and it uses 28 damage indicators, which are these, and these are the charts from the National Weather Service. And examples of the damage indicators are the different types of buildings. They range from a farm, a family home, a motel, a trailer, a hospital, and it also puts on there trees and vegetation that can also be affected. And it also uses a 9-degree damage scale to assess the damage of the specific structure. So for example, if a tornado goes through a neighborhood and it hits a house, you would go to the damage scale indicators and find which building it hit. So let's say it hit a 1 or 2 family residence, which would be a 2. And then you would go to the damage scale indicator, and depending on how much damage it had to the house, you would rate it. And let's say most of the walls collapsed, so that would be a damage degree of 8. And you would go over it and it gives the lowest wind speed and the highest wind speed, and it gives the average wind speed. So based on that, it gives the expected wind speed of 152 miles an hour. And from that, they would go over to the EF scale, and depending on where the expected wind speed is, they would rate it, and 152 would be between 136 and 165. So then they would categorize that as an EF3 tornado. So those are the different charts that they use to categorize the wind speeds. So understanding the way tornadoes are ranked and understanding their power is an important part of weather research to help track and understand and prepare for future storms. Thank you.